In this video, I'll be discussing about Bohr's atomic model. Before moving on to the postulates, Bohr atomic model explained based on the hydrogen atoms, okay, or hydrogen-like atoms. So it is applicable to hydrogen atoms or hydrogen-like atoms, okay, especially when it comes to the numerical problems. Now moving on to the postulates, the first one is a nuclear concept. Here Bohr stated that the atom consists of a small and massive central core called the nucleus, and the electrons are revolving around the nucleus. The centripetal force, which means the force that allows any particle to move in a circular path, okay, is provided by the electrostatic force of attraction between the electrons and the nucleus. Okay. Now the second one is the quantum condition. Here, as I have mentioned, that the electrons will be revolving are revolving around the nucleus. So they revolve around certain energy levels, or we call it orbits, okay, according to Bohr's atomic model. Now electrons will revolve only in those energy levels or in those orbits where the angular momentum of electron is an integral multiple of h by 2 pi, which means L equals to nh by 2 pi, okay, or L is mvr equals to nh by 2 pi, okay. This n can be any integral whole number 1, 2, 3 and so on, okay. Not a whole number, it can be 1, 2 or 3 and so on, okay. Now the next point is, you see, quantum means, okay, it comes from an idea called the quantization, okay, and this h is a Planck's constant, okay, it has a constant value, okay. So moving on to the next one, that is before moving on to the third one, in the quantum condition, the angular momentum, okay, the angular momentum of the electrons are also quantized. It's not continuous, okay, and therefore they are called quantized, okay. Here as I have said that L equals to nh by 2 pi, this h is a constant quantity, okay, having the value of 6.63 into 10 to the power minus 34 joule second. This is a unit of Planck's constant, okay, you have to remember this one. Now the third one is the stationary conditions, okay. Now in those energy levels or orbits wherever the electrons are allowed to revolve, okay, as long as the electrons are in their respective orbits, they will not radiate any energy, okay. That is the stationary orbits. The fourth one is the frequency condition. Here in an atom, the electrons, okay, or like the atoms can either emit, okay, they can either emit or absorb radiation, okay, in the form of discrete energy, okay, discrete energy. So those discrete energies are in terms of photons, okay. Now those energies will be either emitted or absorbed only when the electrons are excited, okay, only when the electrons are excited, maybe, or excited or jumps, okay. Suppose this is a nucleus, this is the shell 1, energy level 1 and energy level 2, okay. If the electrons jumps from level 1 to level 2, okay, energy level 1 to energy level 2, then the electron need to absorb some amount of radiation or energy. If the electron jumps from second level to inner level, the electrons will have to emit energy or radiation. Here it has to absorb energy. Okay, now these are the 4 main postulates of Bohr's atomic model. Okay, there are limitations for Bohr's atomic model. I want you to go through that one.